For this lesson, we're going to talk about the law of sines. The law of sines is used to solve non-right triangle problems. So every problem we've done so far is if we have a right triangle. So now the law of sines is going to help us to what if we don't have a right triangle, how are we going to solve that? Okay. So this is our law of sines. It says that side A over sine of A equals side B over sine of angle B, and side C over sine of angle C. And our triangle is laid out just like our other triangles with the opposite sides and angles being the same letters. Okay. We use this to solve angle side angle or ASA triangles. So that's like we have an angle, a side, and an angle, or angle sides, because you can find the other side. Okay. We don't use it in our other kinds of triangles because it can give us multiple solutions, and we'll talk about that in the next video. All right, so I have a triangle here. And in my triangle, I know that angle A is 33 degrees. I don't have enough room in my triangle. B is 105 degrees, and side B is 37.9. And it wants us to find all the other pieces of our triangle here. I already have 2 of my sides, so I can already find C. So that's going to be 180 minus 105 minus 33. So I know that angle C is going to be 42 degrees, something I just know. I may need to use that later on. All right, so now I'm going to find side A and side C. Side B right here, I have both of the pieces of information, and so I'm going to use that in all of my solvings that I need. So I'm going to set up using this sine of B here. So that would be 37.9 over sine of B. And that is going to be equal to, we'll do C just because it's right here, sine of 42. And so now I need to solve that for C. So I'm going to multiply both sides by sine of 42. And that is going to get me what C is approximately equal to. So you're going to put in your calculator sine of 42 times 37.9 divided by sine of 105, and that gets you 26.3 for the approximation for side C. Okay, which is making sense. And now I'm going to do the exact same thing over here for A, and I'm going to use again that B side that was given to me. It's a 105. And that's going to be A over sine of 33, and I'm going to solve that one. And that will give me a side of A, so I'm going to do sine of 33 times 37.9 over sine of 105, and that will give me a side of A of 21.4. Okay, and we'll take a look. These numbers do all seem reasonable. Okay, we had 3 things, we found 3 more. All right, the next thing says that we're going to look at page 13 in our 313 in our book. So I'm going to open that up. I'm going to try to open that up and see what it says. I think it gives us a word problem. It does. So we're taking a look at the baseball word problem at the top of 313. It says that a baseball fan is sitting directly behind home plate in the last row of the upper deck of U.S. Cellular Field in Chicago. The angle of depression to home plate is 29 degrees, 54 minutes, and the angle of depression to the pitcher's mound is 24 degrees, 12 minutes. In Major League Baseball, the distance between home plate and the pitcher's mound is 60.5 feet. How far is the fan from home plate? So we're going to draw us a picture. I have this fan out here. and he is way up top in our stadium. But my fan is looking down at my field. And he's technically behind home plate. And the pitcher's mound. All right, so my fan is looking at home plate. My fan is looking at the pitcher's mound. And I know the distance between these two are 60.5 feet. Okay. This talks about an angle of depression. So remember, for these angles of depressions, we are looking at the horizontal and down. So the angle of depression to home plate is 29 degrees, 54 minutes. So that means this whole distance here is 29 degrees, 54 minutes. In order to convert that, those minutes into degrees, you're going to take that 54 divided by 60, and that's going to give us a 29.9 degrees. Okay. And then it tells us that the angle from this fan, see if we can write it in this purple and you can tell the difference. The angle of the fan to home plate, that's going to be 24 degrees, 12 minutes. Okay. And that 24 degrees, 12 minutes, if we divide it, is equal to 24.2. All right. As you can see right here, though, our triangle is this one right here. So we actually need to know what this little degree amount is in there. I'm going to see if I can grab another color that you can actually see. Let's see. Try this blue. And we need to take, for this blue angle right here, hopefully you can see it's a little different. We need to take 29.9 and subtract 24.2, and that's going to get us that blue angle right there, which ends up being 5.7 degrees. So that is that top angle of that triangle is going to be 5.7 degrees. The question here asks us, how far is the fan from home plate? So the fan to home plate, that's going to be this distance right here. That's what I'm solving. So I have an angle. I have this side over here. I have this side over here. Okay. If I take a look at information I know about angles, okay, so this is going to be a little bit of a stretch from our geometry. If you look here, we have parallel lines cut by a transversal. When we have parallel lines cut by a transversal, we know that these alternate interior angles right here, we know that they're going to be the same. So we can actually say that this angle down here is 24.2 degrees. So now I have an angle, and a side, and I have the ones that are across from each other. So I'm going to say 60.5 over sine of 5.7 equals x over sine of 24.2. And I'm going to solve that by multiplying by my sine of 24.2 on both sides. And that will get me an approximate distance of my fan from home plate, which is 249.7 feet. Okay. All right, next thing we can use sine for is to find the area of triangles. So the area of triangles says that if I have two sides of a triangle with an included angle, so two sides with an angle between them, we have this formula that works, okay? So these are the two sides with the angle between it. K stands for area in trig because we use angle A as our angle, and we don't want area, big A, and angle A to be confused. So when you see a K in trig, we're talking about our areas. All right, so it says, find the area of a triangle that has a side of A of 4.7, C of 12.4, and B is 47 degrees, 20 minutes. Remember, we're going to just divide 20 minutes. So 20 divided by 60. So this ends up being 47 1/3 for your solving as you are solving that. Okay, so we need our equation that has A, C, and B. So that one right there. So I'm going to say K equals 1/2 of my sides, 4.7, 12.4, and then I'm going to say sine of 47 1/3. Okay, and you can throw that into your calculator. That will give you an area of 21.4. It does not give us our units, so we're going to say units squared. Okay. We also can use a different area formula depending on the information given. So on this area formula, it gave us one side and two angles. Let's try and zoom in a little. So this is a formula we can use for this. It's a way more complicated, but we can still do it when it gives us one side and two angles because we can find that third angle. Okay. All right, so I have a problem here to find that area. It says find the area of DEF if D equals 13.9, so one side, and here's my two angles. These equations don't really matter which one you pick. The biggest thing that matters is that you notice that this side matches the sine of the same angle, the corresponding angle on the bottom. So that means this would be our side, this would be our sine that goes on the bottom. So right now I don't have F. So I need to find that. I'm going to take my 2 degrees and subtract them to find F. Okay, so that's an F of 130.8 degrees. Now I'm going to plug these into my equation. So my equation said I need 1/2 of my side squared times the sine of not D. So the sine of 14.8 times the sine of 130.8 divided by the sine of 34.4. Okay, and you're going to plug that into your calculator. Be careful when you plug that in that this gets squared and that this goes in as one whole piece inside parentheses, so it's all multiplied by that. All right, so that's going to be our K, and we're going to get a K with an approximate amount of 33.1. And it didn't tell us our unit, so I'm going to call that U squared for unit squared. All right, thank you.